Are you okay? Good afternoon, Nathan. Good. What's up? Something sad. It's just a fact of the matter. Oh yeah, I totally forgot. What? You got a bright future. Okay, go quickly. We got stuff to learn today. Okay. Good afternoon, Janiyah. Good, glad to hear it. Good afternoon, Ethan. Yes, sir. Good afternoon, Barry Lee. Good. Hey guys, we're forgetting a lot of us forgetting something when we walk in. Good afternoon. Oh, gotcha. Good afternoon, Trent. Good, glad to hear it. Good afternoon, Devin. And there you go. Good afternoon, Kyla. Glad to hear it. Good afternoon, Emily. Yes, you are. Good afternoon, Lillian. Yes, you are.
Hey, Chris, hold on.
If it's busy in there, come back to the bell ringer and then go.
Okay.
Good afternoon, Aiden. Yes, sir. Hey, by the way, you might want to go ahead and get your notes out from yesterday.
I want to hear it.
Okay. Good afternoon, Joey. Say again. Yes, you are. Good afternoon, is that Jamie? Good afternoon, Jamie. Yes, you are. Guys, get out your notes from yesterday. It will help a lot.
I want to hear it.
I know.
What are you lettering about? What are you lettering about?
One day they got you all this today.
No.
Not for a hot second, because Good afternoon, Caitlin. Yes, you are. Afternoon, bell ringer. Good afternoon, Wesley.
Okay,
Yes, sir. All right, come on, guys. First off, this cell phone caddy is looking quite sad. Let's make sure our phones are up.
How old are you?
you might have last
When
bro.
first?
Oh, you
How old are you? Can you hold it up?
It's better.
I got a I'm going to have to do this today. John,
They don't count.
I wasn't.
Oh, you're right. They don't count.
Wait, like
It's called no red house.
red? Astro now.
I had the video.
Okay, not
I had the video of that.
Good afternoon, Anish. Yes, you are. Good afternoon, Taylor. There she is. What? There you go. Good afternoon, Maddie. Yes, ma'am. I think I've greeted everybody at this point. Not today. These transformation techniques because it's going to help them prepare for the test. It'll either be second half of tomorrow. Oh, not for one. So what we're covering right now is going to include a lot of this, which is unfortunately. So I'm using it to. I'll try to get to it tomorrow.
Oh, thank you.
Where's your pass? Alright, so you're just starting then. Yeah. Yes. We're gonna get started in just a second, so be back quickly. How are you putting the answer in? Ooh, probably should have put it as something different. Go ahead and finish answering the question. I'm gonna have to send a quick poll back out as a different style of question. So keep answering the bell ringer. I'm going to send it back out slightly differently in a second, though. Trent, you ain't even trying to do it, man. Did both of them? Alright, I just sent the new version of the poll back out. You'll be able to type it now. Peyton, do you not have the phone? Thomas is absent today. Is Addison not here either? Jaden, where did Jaden go? Hey Jaden. Jaden Killian. First off, are you supposed to have a hood on this side of the school? You and I both know, what does Mr. Hinton ask teachers to do if they have if students have hoods on? Anybody know? Write them up. You get a write-up for having a hood on, but plainly put. I've asked you day after day after day, take your hood off. This is your last warning, is that clear? Okay. Jaden, did you forget to do something when you walked in? Caitlin, no phone? Jaden, you don't need to text anything, put the phone off. No one seen Jordan today? Maddie, no phone? Carter, no phone? Yep. Little sus. Janaya, no phone?
Why are you doing this?
Hey Joey, no phone? No phone?
Oh, hillside.
Sorry, you need graph paper? Put this up on the Student Work Center and then you can grab some. Hey, by the way, someone left their lunchbox yesterday out of this class. No, it was not just notes. All right. Hey guys, I got 17 to 21 who put answers in. Let's get those answers in more quickly. We're getting started in 30 seconds.
What we did yesterday?
Huh?
I'm going to do it my
4, 3, 2, and 1. Let's look at these. So the first question, if the point -4, 5 is translated right 5 units and down 3 units, what is the new point? I got a lot of 1, 2. I got a couple 2,8s and a couple 2,2s. How did we approach this one? I will say, like,
Made a graph.
there's a really easy way to do it, but could we have made a graph? Thomas, what do you think?
I made it
You what? You just made it up? Is that what you said? What did you say? Coda, was it you who was tardy earlier? Okay, I will point this out. There is a really easy way to do this, but could we graph it? If you don't know the easy way, at the end of the day, 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5. What would I do to translate it 5 to the right? Go right. 1, 2, 3, 4, 5. So here. And then now what? 1, 2, 3. This was A, my pre-image. This would be
A prime.
A prime, my image, right? And very clearly, what's that point?
1, 2.
1, 2. Did anybody see an easier way to do this, though?
I just do simple math.
When you say simple math, what do you mean?
When I just
Subtraction,
addition and subtraction.
addition, and subtraction, right? Like legitimately, if it's going to the right 5, what operation is that? Hey y'all, this isn't lotion class, it's math class, put it up. Addition. To the right is adding 5. What are we adding 5 to though?
-4.
So is that my X or Y? So literally, translation to the right 5, correct? Okay, and then down 3 units, -3 to the 1. That's literally what we're doing. And notice I will point out, writing it like this, if I had multiple points, could I do that to multiple points? Isn't that going to be a little bit quicker than having to graph it every time? So knowing the operations is helpful. I do want to also point this out. Does anyone remember what this little arrow would be called for that translation?
Vector.
That's the
Vector.
vector. Remember, the vector is telling us how far to translate that point, right? So that, it looks kind of closer like a ray, not a line segment, because it has an arrow on the end, but that thing there, I'm just going to say that for now, that thing there is a vector. It's describing that translation. Yes, ma'am? I mean, if the point was here and then here, that would be my vector. You'll study vectors more in maybe like a physics class or a pre-calculus class, but all a vector is it has magnitude and direction, and what that means is it has length. Does it have length? That's my magnitude. And then the direction, it has an arrow literally showing me which direction it goes. That's what makes it a vector. Does that make sense? Okay. All right, and so the vector can go in any direction. It just depends on the translation. Let's look at the second question. The point -4, 5 is reflected over the y-axis. What is the new point? Not 4/5. 4, 5 is the most common answer. How are we figuring that out?
Because if you reflect it from the negative one, go to the positive one, and then the y will stay the same because you reflected it across the y-axis.
Okay. So yes. So 1. Okay. Let's reemphasize. Can I just graph it? Yeah. And if it's 4 to the left, a couple of key details to remember is you always reflect across or using what type of line? You go across the line of reflection, but you need to be what to that line of reflection?
Parallel.
Perpendicular.
Remember, it needs to be perpendicular, right? You always reflect, that is gross. You always reflect perpendicular to that line of reflection. And how far do you go to the other side?
The same amount.
The same amount, right? So if that's here, I need to go to the other side the same amount, right? Which, if it's 4 to the left, now it's 4 to the right, and the y does stay the same.
Oh, I see what I did. I didn't realize that it gave you the point to reflect, so I just reflected the answer to the last question.
Oh, I got you. So, quick detail I do want to point out here is, I think Jamie was referring to this earlier. She was saying it's across the y-axis. So why did you know that it was the x you were going to multiply by a negative and not the y?
Because the y is going to stay the same.
How do you know that though?
Because that's the one you're reflecting over. It's just going to be an opposite.
But why is it not the opposite of the y value?
Because you're reflecting over the y.
Okay, we need some more details in there. Joey.
The line you reflect over, that one stays the same.
Okay, that's part of it. Okay, there's two things I want you to pay attention to here. First off, if you're reflecting over the line, the y-axis, right? What kind of line do you have here that you're reflecting along? A horizontal. It is perpendicular, but if it's perpendicular to something vertical, then it is horizontal, which means it's going in which direction, x or y? It's going in the x, so which variable is going to change? Yes. Does that make sense? And that's the bigger thing, and a lot of students, hear me very clearly on this, a lot of students get very tripped up on whether they multiply the x or the y by a negative, because they're like, oh, it's the y-axis, so I'm going to multiply the y by a negative. However, if it's across the y-axis, it's which direction? Well, is it vertical or horizontal? It's horizontal. And the x is horizontal. So if it's across the y-axis, right? If it's across the y-axis, it's horizontal, meaning it affects the x. Does that make sense? And what operation always goes with a reflection? Or at least across the axes? What mathematical operation? I thought addition went with the translation.
Multiplication and division.
Multiplying by a negative. Literally, it went from -4, 5, right? To a positive 4, 5. Multiplying by a negative or getting the opposite is what we see when we have a reflection across the axes. Alright, so there's a little bit of review from yesterday. I need all of our notes out from yesterday. I don't know why some of us didn't already have those out. Yes, Karia. No, you're never allowed to use the restroom ever again for the rest of your life. We're about to start. Alright. So, we're going to continue working through that TI Inspire set of lessons on transformations, where we are defining each rigid transformation. We already started on this yesterday. What are the 3 rigid transformations? Reflections, translations, and rotations. And we, at the end of yesterday, right, and then we're going to get to that review, that's the rest of the packet. Right now, remember, we're trying to define each rigid transformation, identify preserved elements under each transformation, and we got to hear yesterday. When we finished these reflections yesterday, what was the last thing that we said? What was the last thing that we started to note? We talked about one thing after that. Because we noticed something that the translation and the reflection had in common. You say it, what are you talking about? The angles, the area, side lengths.
Are all created
Right, so the angles, the side lengths, the area of the pre-image and the image were the same. Do you see this language right here where it says I can identify what type of elements?
preserved.
Preserved. What happens when something is preserved? It's kept the same, right? And so we're already noticing with translations and reflections, at least those two rigid transformations, the length, the angle measures, and the area are all preserved. They're all staying the same, okay? So we need to check this though, right? Two of the rigid transformations, that statement is true. Notice that's a pattern, because what is mathematics at its core? Study of patterns and relationships. We want to notice that a translation, the pattern or relationship, is that we're adding or we're subtracting. With reflections, especially across the x-axis, the pattern was that we're multiplying by a negative. But there's also the big pattern that with those two rigid transformations, the angles, or the angle measures, the side lengths, and the areas are all the same, so they are preserved. We need to check to see if that pattern still holds, right? As mathematicians in my class, we want to notice patterns and relationships. We've done that. We've described these patterns and relationships as well. Now we need to generalize. Let's see if this holds up with this last section, right? So we are now moving, we've done the reflection. We're now on this section about rotations, pages 5.1 to 5.3. I need you to open up the file on the calculator. We should still already have that file if you go to documents, but I can send it back out if you need me to. Joey, we can't be falling asleep. Come on, my man. We got stuff to learn. Hey, Jaden, come on, get on that calculator. We got to be on our calculator if we're even attempting to do this rotation. Who needs me to send this out? Coda, Wesley. Coda, Wesley, who else? Maddie, Caitlin. Alright, I'm just sending it out to everybody.
Yeah.
That way it's done. Alright. Ooh, I forgot to mention this. Before you move to 5.1 and 5.3. Huh? Go to Documents. Documents, Browse. Are you on? Yes. Okay, there it is right there. Okay, really quickly, I want to point this out. Notice this reflection is not across the x or y axis, but it is across, does anyone know what this line is? Right, but what is the equation of this line? Anybody know? So in general, it is y equals mx plus b, but what would the equation of this line be? What is the slope of this line? So if it's 2 to 2, what's 2 divided by 2? So y equals 1x, and what's the y-intercept? 0. So this is just the line y equals x. That's what I want you to notice, right? We're reflecting across the line y equals x. Notice when we reflect across that line y equals x, it's not as simple as just multiplying the x or the y by a negative. There's more going on there. But does it still look like we are reflecting perpendicular to that line? Does it look like that distance is staying the same? And so I want you to notice, like, we mostly will focus in this class just across the x and y axis, but that idea of reflecting perpendicular to the line of reflection and the same length to either side will always hold true. Does that make sense? Okay. Did you have a question, Maddie? All right. So here's where we're looking right now. I want you to explore 5.1, 5.2, and 5.3. Okay? And so I realize I need to be a little bit more clear. Question 1 still holds, right? Question 1 just says, what rigid transformation is being applied to the polygon? That should be pretty straightforward. What do you see that informs you of this? Answer number 1 as is. But when you look at the second question of what do you notice and what do you wonder, I want to be more clear. With 5.1, how are the clockwise, by the way, clockwise will always abbreviate as CW, and counterclockwise rotations related? Okay? There is a way that the clockwise and counterclockwise rotations are related. Make sure that when you grab this point, you're going to go clockwise, like you're going around the clock. When you grab this point for Q, you're going to go counterclockwise, as if you're going around a clock. And so they are related somehow. That's what I want you to explore on 5.1. On 5.2, I think, hold on one second. Yeah, it's just as is. They only give you one point, point A, and A prime. Notice there's a whole triangle, so you can explore it more, but point A and A prime are already given. You can go through multiple angles of rotation, right? But what I want you to focus on is this, right? When you focus, how are the points of the pre-image and image related after 90-degree rotations? And then when you get to 5.3, the question you want to be asking is, do the patterns for translations and reflections hold up? So I need to be more clear about what I'm looking for you to notice. Those are the things that I'm looking for you to notice on 5.1, 5.2, and 5.3 and answer the question on the sheet. But also, start thinking about what do you wonder. I cannot emphasize this enough. When you look for what you notice and you start to wonder and ask questions about things, it makes the math more interesting. I know that we don't love math for some of us, but I guarantee you this, if you follow my directions, it can be better. So, follow the directions. Move through 5.1, 5.2, and 5.3. Collaborate as a small group to answer number 1, and then move on to number 2 with those questions in mind. Just make things easier. Yes, ma'am.
When I click on the lesson, it's just blank.
Did it not go out to you when I just sent it a second ago?
You said you
Alright, we'll send it back out to you. There's a lot of silence for us to be actively collaborating. You get it now? Hey, you're not even trying, dude. What's going on? Dude, you wrote one word down.
Just there, no screen.
Rotation. Wait, where is it? No. It doesn't say, but if you look at the later ones, it says rotation. Why is it rotation up on the board? Come on, dude. I'm trying to do the list. That's not gonna work in my class. Do some more. Collaborate with your group. Talk. Jake.
Oh, there you go.
Wait, what are you doing? Stop that. Why are you moving that? No, guys, you're only clicking on points P and Q on 5.1 and rotating that way. On 5.2, you're only moving the slider. Right? Someone's already right. Have we actually talked about it yet? But have y'all talked about it in a small group? Have y'all talked about it yet?
You can learn as long as it's not left or right. No, left or right.
You gotta actually like go through.
Then I can circle it.
You could have just pressed the arrow. That probably would be easy.
Probably.
Yeah.
But I'm already here.
Because the plot was rotated no matter what. It'll just be the same angle.
What? It's 10th and 11th.
Just asked you.
Algebra 1 is 10th. Algebra 2 is 11th.
I asked you first. Bro, I asked you first.
You tell us
No, you
Yes.
didn't.
I said rotation.
You said that 2 minutes after. Then you just said it like, what, 10 seconds ago.
10 seconds ago, you just started going on. 10 seconds ago, you said, that's why I hate black people. But I'm saying though.
And isometry is only one at a time.
You gonna say something you close to, you said a minute ago.
I ain't know it's like going down. You feel
Or
me?
you could've, but he said 10 seconds ago.
Exactly.
That's way off.
What you think, girl?
I said rotation.
No.
Okay, so what you think?
No.
You just saying
I
that
want
because
you to
I
learn.
Tell me what you think.
No, because if you're competing, you're not trying to help each other grow and learn. You're trying to be better than somebody else, and that's not the goal.
Okay, we're not competing.
Answer the questions.
Number 1, 2. What's it right? I can't trust you.
Ain't it too?
Okay.
Why are you
All right.
riding?
I am tired of y'all sitting around and doing the absolute least. You all have a different place to go in this room. Group 6 is over on that TV. Groups 5 and 4 on that whiteboard. 2 up here. 3, 1, and that's supposed to say 7, not 5. 7, you're here. Get up, go to somewhere on the board, and actually collaborate with each other to answer these questions. We'll have a whole class discussion about it. So don't worry about writing on your paper right now. Take the paper with you to be able to answer the questions. Get your answers on the board though. Let's get to work.
Hi.
You need to actually collaborate and make sure your group agrees.
No, we're not doing it.
Oh, by the way, here's some chalk. There's chalk. Hey, group 6, let's stop worrying about being cute with the colors. Let's get our answers on the board. Let's collaborate.
Rotation.
How is it supposed to erase?
Answer the questions, Coda. You use, look, guys, if you're on the chalkboard, use the washcloth to lightly erase. Answer the questions. Don't draw the figure. Answer the questions. Y'all make it too hard. I need to see active collaboration. Hayden, you're not even near your group to talk with them. Anaya, Thomas, y'all just let Lillian Wright talk about it. All right. I was like, y'all should have your calculators, guys. Guys, you need your calculators with you.
Are you recording?
I am.
Can you get that for me? Because you got taller.
Jamie, do you need your calculator?
Hey, you're in group 7, right? Isn't there a piece of paper right there that has the questions on them? And then I have those questions up on the board. You got a brain, girl. Use it. Let's get on it. Let's get it working again.
You're going to be right.
If it goes clockwise or counterclockwise, it's the same.
Yes, sir. Aiden, you haven't even done anything yet. Get together with them and talk.
Let's go to translation.
Come on, guys, we got one word up there. We need more. Come on, group 6.
It is a rotation.
Hey, group 3, y'all know you're not supposed to use your hands. There's washcloths over there to help you lightly erase. But we're using the word rotate to define a rotation, right? Look right here. Look at this calculator. What do you see here to tell you that we have a rotation?
Rotation is a positive.
Throw some words out there. There's some angles there, aren't there? Like if I go from that point of rotation out to that point right there, I see an angle that has been gone through to map that point to right there. Could that be what's defining that rotation? I mean, yeah, like, do we see something like that up here as well? There's some information. Come on, use our language. Let's work on it. Hey guys, don't forget, there's, and try to scoot over for me a little bit. There's 3 questions specifically, one about 5.1, about 5.2, and about 5.3 that we need to start thinking about. I will point this out. I think that green that you have is actually addressing one of those questions over there. That's not what tells us that it's a rotation. So it's okay. Leave it as is. It's fine. I just want you to be aware. We're going to have to add more to what you're saying about a rotation. That's why I'm not having you write it down. Okay? I could see you kind of thinking that, but notice it's an angle of. I'll tell you. I'll show you why it's not a reflection in a second, because it does look like one right here.
That we gotta find out how the points for the pre-image and the image are related to the negative rotation. I mean, yeah, if you wanna write on the thing.
I'll say this, part of what you already wrote in purple actually answers part of one of the things I
Oh, you said the flame. I actually did.
we don't talk to each other like that.
Why you my feeling back?
I'm going to give you about 3 to 4 more minutes to get all the ideas that you can up on the board, then we'll go over this, but come on, let's get to work. Yeah, we're supposed to be on number 2. We're supposed to be answering those 3 questions.
Okay. Circular motion. How I said. Right, what I just said.
Okay, we do gotta. You just asked for the
Right.
Like I can't write that.
It is just you 2 today. Wait, why are you erasing that idea of the opposite?
No, we just erasing them both.
Why?
They both move in circular motion. I'm not wrong. I'm not wrong.
If I look from the origin to here, it's going up. It looks like, and it's probably just a scale. But if I just look at it, it looks like it's going up 2 into the left 1, doesn't it? And I know it's not that because, oh no, it's point A that it's approaching. So if I look at B, it goes up 2 into the right 1. Yep. If I look at B prime though, it's going to the, it's going down 1 into the left 2. Is this? I mean, up 2 to the right 1, and to the left 1 is negative 2, isn't it? And if I go down 1 into the left 2, that's 1/2.
Yeah.
Because, hey, quick question, what angle measure did it rotate? 90 degrees? Look at there. What happens when we start to look for patterns in relationships? Yes, sir. Yes. You better run like a blazing bullseye, because we're getting started in probably 90 seconds.
Oh, what?
Oh,
we can sit down and nap.
no, we cannot.
If you want to take a 0 on your active collaboration scores, you can. That's my thought.
You can write it. You can write it. I said they both move in circular motion. Don't be
Related.
It's your idea, so right?
I can't write it. You write it. I see you. What did you do? I put the egg roll back. So you did. I did basically all egg roll. I did all this. You can ask me. That's why I did. You straight.
So they still gonna play Mario?
Give me the pen.
Thank you. Thank you. Thank you. Let's go back to our desk and let's talk about these. Looking at the answers that we developed. All right. First couple of details should be very straightforward. What type of transformation are we looking at? Rotation. Rotation, right? Now, the next part of this, though, is actually critical, and we need to pay attention to this. And I think that a lot of us actually see it, but we're not quite getting there on explaining it. What do we see that tells us we are looking at a rotation? Okay, clockwise and counterclockwise might indicate it's a rotation, but there's something else there.
But it's rotating.
The polygon is rotating.
The polygon is rotating, but you're literally using the word to define itself, right? Emily, what were you saying that you see? Those degree symbols, which means we are dealing with, what is this called?
Angle.
Angles. Right? There's an angle that is relating the pre-image to the image. And we get those angles because of the rotation. Like, that's what we should notice. When we look here at this point of the pre-image, and we draw this line, does anyone know what this point is called, by the way?
The vertical line.
Vectors go with translations. Lines of reflections go with reflections. This would be the point of
Least resistance.
rotation. It's called rotation, right?
I just try.
I know. But I'm pointing out, now that we hear that, it's called a rotation, right? This would be considered the point of rotation. So, that right here, that angle is defining how far the pre-image was rotated. How far was it rotated? 150 degrees. I want to point this out because it's not there because there's been too much information, but here's a line that connects to this point, right? Where's the image for this point? Is it here?
No.
Here?
No.
Here?
No.
There's only 3 points, Joey.
I thought you were including the other point over there.
Anybody want to take a shot in the dark what this angle measure is?
150.
No, what, wait.
190.
Why do you think 150, Joey?
Because it's the same as the other one.
Oh yeah, we rotated it, right?
Yeah.
Should it have the same angle of rotation?
Yes.
Yes. Look at this point right here. So I'm going to erase this now. Look right here to right here. What is that angle measure probably? 150. I want you to notice that when we talk about a rotation, every single point has been rotated some angle measure. That's how we know we have a rotation. That's the key, the angle measure. That angle measure is what tells me that we have a rotation. Because if we have one point that looks like it's been rotated, but a different point that would be rotated by a different angle, you didn't actually rotate it. Notice here, like, there's no rotation that would take this point to here and this point to here. That's because there's a vector that translates it, right? If I were to reflect, it looks like I could rotate to here, but I can't do that same rotation to go from here to here, right? So rotations are the ones with that angle measure. And so that's the key thing here. Now, let's look at some of the questions and answers that people came up with for 5.1. How are the clockwise and counterclockwise rotations related? It keeps all the angles the same. Yes. Neither P or Q line up. They're opposite operators because clockwise goes right, kind of. I'll point this out. If I look here going clockwise, it looks like it's actually going to the left. And then when I get up to here, it looks like it's going to the right. So you never want to talk about clockwise or counterclockwise as left or right. Okay? That's why it's clockwise and counterclockwise. So be careful about that. I see the statement that they will not be the same. They move opposite ways but still in a circle. Okay, so I want y'all to look at this. Is there a way maybe to get this counterclockwise to map to the same as the clockwise? How do you know that they're mapped right now? They came together as one, right? They literally are on top of each other. And you're right, the angle measures are not the same. But let's look at the pattern. We always want to look at a pattern. So right now, clockwise, we're looking at 150 degrees. Counterclockwise, we're looking at 210 degrees. All right, I'm going to change my clockwise rotation. All right, so now at 300. Let's look at our counterclockwise to map. Okay, counterclockwise is 60. So 300 degrees for clockwise, 60 degrees for counterclockwise. Anybody notice a pattern?
300 plus 60 is 360, which is not human angle.
Okay, 300 plus 60 is 360. So, yeah, you're not going to like this, but I just need to go ahead and show it to you. Oh, it just starts over, just kidding. Be careful. Angles can technically go above 360 degrees. Has anybody ever played Tony Hawk's Pro Skater?
No.
I'm glad some of us have.
Like on your phone?
I mean, you can get on your phone. I played the OG on the PlayStation 1, so that's kicking it back to the mid-90s. But,
Like back in my day.
yeah, back in hey, regardless, if you've ever watched BMX, you've watched skateboarding, or you've watched rollerblading, anything, how should you know that you can have more than 360 degrees? What's a trick?
That people going on like 720s.
People have done 720s, they've done 900s, 1080s, 1440s when you get into snowboarding. Because what that means is you've done more than one full circle, right? So be careful because it's going to impact what you study in later maths. Be aware that if it's one full circle, it can only be 360, right? But if you have more than one full circle, it'll be more than 360. So be careful about that. Huh? No. No. Yep. No. It does not just start over. So yeah, 300 plus 60 is 360. Does anybody else notice any other patterns or relationships here?
150 plus 210.
Is 150 plus 210 also 360? Okay, so let me move my counterclockwise one more time. Let's make it 240. Or my clockwise is 240. Based on what we see right now, what Joey pointed out, what would we expect our counterclockwise to be? If clockwise is 240, what would, how much? 120? Let's check it. So counterclockwise to, 120? Huh.
Ding, ding.
Do they map to each other? Uh-huh. So let's look at one last one. So answer someone's question. So if the the clockwise rotation is 0 degrees, what does the counterclockwise need to be?
360.
So if those images map to each other, that's the language, the sum of the clockwise and the counterclockwise rotation is 360. That's going to help you in a future component. But what we say, so with 5.1, what we want to note is if the sum of a clockwise and counterclockwise rotation is 360 degrees.
Right.
What? Trinity, she's like looking out for you and telling you like this might be useful information to write down.
Not page, paper.
No, it's like right in front of you. The sum of the clockwise and counterclockwise rotation is 360. The images will what? What do we see if they they what? We would just say they map. Is the language. Notice how it looks like just one image, right? The images map. Right? So if the sum of the clockwise and counterclockwise rotation is 360, those images map to each other. And that's going to be important for 5.2. Yes? Go to the question before class or at the very beginning. So you can look at multiple angles of rotation here, right? But I specifically, right, so like here, A is 60 right now, but I specifically asked you to look at which angles of rotation. Multiples of 90, right? So here's an example of a 90. I noticed a couple of things I definitely want to hit on. We noticed that on 5.2, the rotation in the negative direction is clockwise, and the rotation in the positive direction is counterclockwise, kind of. Looking for more. 5.2, something about the opposite and reciprocal, so it's perpendicular. First off, I want to point on something like, what word is Group 7 using in 5.2, their answer to 5.2, that's making what they're talking about unclear?
Reciprocal.
No, it's. If you are ever using the word it, I don't fully know what you're talking about. Stop using the word it. Be clear with your language. All right? The angle of rotation is opposite and reciprocal? So I'll point this out right now. One of the things this is important to notice is that, does anyone know where the point of rotation is?
Point A? I don't know, I just get A.
It's in the middle.
It's the origin.
Oh.
Notice,
It's 0.
there's the origin, right? If I look at C here, what does it look like the angle is between the green and in between the orange? 90 degrees maybe? That would make sense, wouldn't it? So let's look at it. They're talking about opposite and reciprocal. And you focused? Because it looks like you're playing with your hair once again. So when I look at this point B right here, that's -1, 2, which means if I look at the slope of this, it's going up. How far?